Hi everyone, so in this video lecture we are going to construct a primitive version of Instagram. So you would be thinking, why are we doing this? The purpose is to revise what we learned about structures, revise what we learned about classes and objects. Remember, we have already discussed this in class. Then we'll talk about what is the difference between classes and objects and structures and we'll see that essentially structures are used in some other cases, classes have another use case, so we'll get into that. Then we'll get into something called mutator and accessor functions, sometimes called setter and getter functions colloquially. And then we'll get into constructors and initialization, double pointers. This is something that we discussed, but we were confused about this, unfortunately. So we will discuss this again in the context of this activity, and then finally we'll discuss destructors. So you can say this is a 7-parter lecture, 7 episodes. And if you have any questions, you can post them in the discussion forum, or you can ask me in my office hours or on Monday. So let's begin. So let's start with understanding what an Instagram user has. User has some properties, like, so first of all, they have a user name, they have some sort of date of birth, and most of the times I've seen a lot of people have statuses. I guess that's what they are called, status, where they put something corny on their Instagram profile, like live, laugh, I can't even type laugh and love, something like that. And this is what we'll focus on for now, but we'll build upon this. So let's say name. So we can build a user and just allocate them a string called name, and then we can change this. But this is not fun enough for many reasons. One of the reasons is that if you remember Instagram, making a profile on Instagram, you would remember that it asks separately for first name, last name, or middle name sometimes. So I would need to store first, last, and middle name separately. So easy, right? I can just create a string first name or string last name or something like that. But this seems inefficient, and this seems a bit too primitive. It should be part of the same data type, name. These two shouldn't be separate fields. These two should be combined within one field. So to do that, we can basically aggregate these different data types using something called a structure. We use the shortcut called struct, and let's call this name with a capital N, and we can then have string first name, and then we can have another string last name. And this way we have aggregated two different data types together into one data type called name. The same thing we can do about date of birth. Instead of doing integer month, then integer year, instead of doing all of this, what we can do is we can aggregate that into a single data structure called DOB, date of birth. And then inside this structure I can have integer year, integer month, month, oops, I can't type today, integer day, right? And now this is much more cleaner, much more efficient. Excuse me, struct. Yeah, this is much more cleaner, much more efficient. Instead of having two strings, separate strings for name, I have aggregated them into a data type called name, and they're part of the same data structure. And over here, similarly, instead of having three different integers called year, month, and day, which are not connected in any way, I have aggregated them into the same structure called date of birth. And now I can use them in creating my Instagram user. Notice, instead of using a struct now, I'm going to use something called a class. And let's call this person, you can call this a user, let's call this a user. And over here, I can then have their properties, will change this name later on, and this can be this should start with, in fact, name. We'll call it just name, yeah. And this is the data type, and this is the variable name. Similarly, we have the data type date of birth that we have defined ourselves over here, and then we call it a small dob, right? And then we can just have a single string that we call status. I guess this is what it's called. I can't remember what it's called, but yeah. Okay, status. And now we have created a user. But notice this is a class and this is a structure. And this is where we get to the difference between classes and structures. Going back to the history of structures and classes, structures were introduced in C and classes were introduced in C++. So when structure was introduced in C, this had nothing to do with object-oriented programming. All it did was aggregating different data types together. That's it. That's all it did. So, and in fact, in C++, that's what we are working on here today. I can have member functions or methods included over here, and these can be functions, let's say void change name, and I can pass in a constant string, basically, oops, excuse me, I'm not typing today well, and then I can change the name over here. Let's say first name is equal to, over here, let's give this variable name fn, first name, and I can do this. Basically, the idea is in modern C++, the structures can have a member function. This was not the case in C. In C, they used to have only aggregate data types. And to be honest, this is how it's used in modern C++ as well. So that's one difference in their use cases. Structures are used only for data aggregation, while classes have a much more wider use with member functions and whatnot. On the other hand, the more important difference is that these variables are accessible outside to any function. I can just create something like in my main function, I can create a structure, let's call it a name, and let's do NAM, and then I can basically go and access name dot first name, and I can change this to okay or something like that. But with class, you don't have this privilege. In structures, by default, everything is accessible to everyone. In class, everything is private by default unless you specify that it's a public data member or a public function, right? So this is the main difference. So whenever you have to have data encapsulation, which means you have to hide data from the rest of the code because you don't want any other function to change that data. So that is why we are going to create a class of user instead of a structure of a user. Now that we know these things are called member data or data members, however you want to put it, data members, and then there is something called member functions. I can't type for some reason. Functions. And these are the functions that are going to be your interface to change the name, the date of birth, and the status. So the first thing is you need to differentiate between what is private and what is public. What do I mean by that? Now, all of these functions, whatever I define over here after public, these are going to be public, these are going to be available for the rest of the code. On the other hand, these data structures, these data objects, they are going to be hidden from rest of the code because we have called them private, and only using these member functions you are going to be changing these data members. And the important concept here is data encapsulation and abstraction. You want to create an interface. First of all, you want to hide this data from rest of the code so that you don't change this accidentally, and then you want to create an interface for other users and for yourself to use this class and to use these data members to do whatever you want to do, right? So let's create this interface. First of all, let's start with some functions which are called accessor functions. Let's start with mutator functions. These are going to, as the name suggests, mutate the data. So let's define the void set name function, and this is just going to set the name. So we can declare it over here and just stop, and then we can define this outside of the class, right? So let's do that. Actually, how do you do this? You're going to go over here, and then you are going to do void set name, right? But you will immediately notice that this set name has nothing to do with this set name, because this set name was defined within this class of user. So you will have to specify that this belongs to the user class. Then and only then you are going to be changing this declaration over here. Otherwise, this is going to be something else. If you don't do this, if you take this out, then this set name function is just a distinct set name function that has nothing to do with this class. So let's do this, and this is what it means. This belongs to the user class. Now, how am I going to change this? Well, you're going to pass in strings, right? You're going to pass in strings like this, and you can call it constant string. You're going to pass in two strings, basically strings, one for the first name and one for the last name, and you'll do something like this. And you see already, I see this red line. This means basically my declaration over here doesn't match the way I'm trying to define it. They should be similar. They should be the same. They should be the same. So I'm going to do this and just give this first name, and give this variable name last name. Notice I don't need to define the variable names over here in the declaration. I just need to define their data type, right? And over here I'll just do, now because this is a member function, this can actually access these private data members. So I can just do something like this: name dot first name is equal to f name, name dot last name is equal to l name, right? This is what I can do. So let me show you this. Actually, let me show this over here. Implement this. Let's say I create a user. Let's call user A, and let's say I don't know about how classes work, and I try to access name directly. I do a dot name is equal to, okay, that's my name. I do try doing this, and immediately I see an error. And let's read the error, and it says it's inaccessible. And it's inaccessible because we have made it inaccessible, so I can't do this. So if I need to set this, then I will have to do something like dot name and pass in my first name here, and pass in the second name Salim. And this way I am going to, I'm going to do set name. I'm going to use the setter function over here, and this way I can set the variable. This way I can access the variable. Alright, let's create another setter function. That would be void set date of birth. I guess you saw this coming. It would have 3 integers, right? I don't need to specify the name, as I said. And in the declaration, by the way, you can define it within the class. Let's, for the sake of learning, let's define it inside over here, and in that case you will have to give it a name. So I will have to do year, month, and date. And then, as I said, because now we can access the data members, because we are part of the class, we are part of the family, as you can say, dob dot year is equal to y. We can do this. Dob dot month is equal to m, and dob dot day is equal to d. Most of the times we don't want to do this. We don't want to define the function within the class definition, and you'll find out why in this lecture actually. So for now, we'll just take this out over here, and we'll just let set dob. We'll just keep the declaration over here, excuse me, and we'll take this out. And remember, unless I tell this that this function belongs to the class user, it won't even know what this is. It won't even know what dob is, because dob as it says undefined. DOB is only defined within the scope of the class user over here. So I will have to tell it that you belong to the user class, and then it easily identifies this DOB variable, right? So let me fix the indentation over here, and now I have two setter functions. Let's make a setter function for status quickly, and it would just need a string. By the way, I just realized I have not been into what does it mean by constant string. So some of you already know that this thing means pass by reference. Let me put it in comments. String and an ampersand sign, this means pass by reference. Instead of passing a copy of the string into it, we are actually passing it by reference, so that we don't have to copy the entire string data structure. We would just give it a reference to the original data. But why constant? Why are we making it constant? Because we are not changing it, right? In this case, for example, set name, we are just using it to set the internal data structure. So in that case, it is wiser to tell compiler, hey, we are not changing this string. This is just a constant. We are going to assign this string to another variable, and this makes the program faster and efficient. Moving on, yeah, we were working on the setter function for status, so set status, and now we have the declaration over here. We will use this declaration to define it outside over here. By the way, we will have to do user to let it know that it belongs to the user with stat status, and then let's do basically status status is equal to stat. This is what we'll do, and this is a setter function. So let's revise where we are. We have started with a primitive version of Instagram. We have been into structures. What are structures? We saw some examples of structures such as name, which has aggregated two different data types, first name and last name, string first name and last name together because they belong together. We don't want them separately, right? And then we went into classes and objects. We haven't seen objects yet. We have seen classes. Our class is that of a user. We have seen difference between private and public. Basically, public is the interface that you and other users using your class interact with. Private is the private data members of this class that are not accessible to outside code. And why do we need that? So that we don't change this data type by accident, because this data type is actually important. This is user's name, user's date of birth. We don't want this to be changed accidentally. And then we went into the difference of classes and objects, and then we started with mutator functions. So we have created mutator functions. These are also called setter functions. That's why I am calling them set name, set date of birth, and set status, right? So these are setter functions, and these are mutating these data types. But what about accessor functions? Let's create an accessor function over here. Accessor, sometimes also called getter functions, right? So as the name suggests, it just returns the name, it just returns the data type, date of birth, and it just returns the status. So it should be, because the name function, the get name function, does not need any input, does not need any arguments, because it's just returning the name, and its data type, return type, should be name, right? It should return the structure name over here. That's the declaration for get name. And similarly, we have dob get dob. This will return the date of birth, and then we will have a string, because status is string, get status. And this is simple enough. Over here, using these declarations, we are going to create the definitions. And remember, as we said, you have to specify that these functions belong to user. Otherwise, you are going to create a confusion, because compiler wouldn't know what these functions are doing, what these functions are accessing, right? So let's change them one by one. This will just return something like the name, N-A-M-E, name. This will return something like return the DOB, and this will return the status. Now, for function like these, which are a single line functions, they are usually preferred to be defined within the definition, within the class definition. And how do we do that? Instead of doing all of this, what we can do is we can basically comment these out, and over here within this function we can do return the name, right? And we can do something over here, return the DOB. Let's see if DOB, nope, DOB, yeah. And over here we can do return string, or return status, excuse me, yeah. And as you notice, I forgot the braces over here, so it's showing me a red line already because it can't understand what's going on. And yeah, you can have, excuse me for my spelling today, let's look into what are constructors and initialization list. So let's start with constructors. Constructors, as the name suggests, are a special type of function, you can say, which are called in when a user is created. This over here is an object. This is a user object A. Whenever this object is created, a function would be called, that is called a constructor function. But right now we haven't defined the constructor function. Let's define a constructor function and see why it is used. So it is going to be a public function. We will define it over here, constructor, and the name of the constructor is always the name of the class itself. So it should be user, and this is called a default constructor because we are not passing in any arguments. Whenever we don't pass any arguments, just like over here we haven't passed any arguments when creating A, this will be the default constructor. This will have the default values, so we'll use this to set the default values over here. So let's do that. So one way to do this, so we will go outside over here to define this, and you will define this as user. Now let me explain what I'm doing over here when I say user. Now notice that a constructor does not have a return type. Why? Because it's not just any function. It's a special function that is automatically called upon when an object of that class is created, and it is used to initialize the data members. So it does not need a return type. It is used only for initializing the data members. Now, secondly, when I am defining the user constructor outside, notice unlike other functions, I am not using a return type because it does not have a return type, and I'm doing something funny, user : user. What it means is that we are going in the class user, and then we are defining the function user. That's what it means. Similarly over here, it means that this is a function with a void return type. This belongs to the class user, and the function of the name of the function is set name. And let's define the constructor over here. The naive way, the way that people used to do before C++11 or in C++11 is this. They would go in here and they would basically do something like dob dot, okay, let's start with the name dot first name is equal to, by default we are going to put nothing over here, or you can, let's do a dash over there. If a user is created without defining their name, then we would have a dash over there. And then we will have the same thing for last name, last name, we'll create a dash for them, and then dob dot, let's start with year. If they haven't defined what year it is, then that's by default it is 2000. Dob dot month, it is 1, and dob dot day is also 1. So these are the default values that we are giving to the user. What else? Let's set a status. Let's status this is a spelling that I keep forgetting for some reason, and this can be default like, hey, I am using Insta. Let's call it primitive Insta, because this is a primitive version of Instagram, right? This way, whenever a user object is created, for example over here, it would be given some default values if we are not giving it any values ourselves. So let's see. So over here we have created user A, and we'll just access a dot get name, and we'll see what's its first name is, and we'll print this out, right? So we'll do cout a dot first name ENDL. By the way, for those of you who are confused, a dot get names returns a structure called name, as we have defined it over here, and that structure contains first name as a member. So when we call get name, we get a structure name, and we have to then access it using dot first name, and we'll get the first name. And what do you think the output should be over here? Let's run this, and the output over here is a single dash, because that's the default value this user has, right? And that's a default constructor for you. Now let's get into why the way we define a default constructor here sucks, because as I said, this was the way before C++11, and in this course we are doing C++17. So the modern way to do it and the efficient way to do it is using initializer list. So let's get into that. We'll create a user function like this, but now we'll create a list. Before even defining what a user constructor does, we will define an initializer list like this, and then we will initialize every data type one by one. Alright, so let's do it. So name is a structure which has two parts to it. So for a structure, we will call the initializer list something like this. We'll do name, we'll do curly brackets, and we'll do basically dash. That's what we did last time, right? Dash comma dash. This basically says we are going to call the data structure name, and we are going to give it the first name dash, the last name dash. Then we are going to do another comma, and then we have date of birth, right? Because this is a structure, we'll use curly brackets. We'll do 2000 starting with the year, month, and day. This will call the data structure DOB, will initialize its data members with these values. And then we'll call the third one, status. And notice that status is not a structure as we have defined structure name and structure DOB. It's a data type in itself. So in that case, we will basically use round brackets and use status, hey there, I am using a primitive Insta, right? And this thing is called an initializer list. This will initialize everything automatically. You don't need to do this. So let's look into why we moved from this in C++11 to this in C++17. Basically initializing within the body to using an initializer list. And the reason is efficiency. When we use initialization within the body, what happens is first a data structure name is created, and then a string called first name is created. Now whenever a string first name is created, it calls its own constructor. String would call its own constructor and would assign its own default value, and then and only then we are going to assign it a dash. So there are two hidden initializations going on over here, which makes it inefficient. Similarly, for in case of integers, first a data structure called DOB is created, and its data member year is created, and it is assigned a random garbage value. just like when we used to do like int xyz. This is assigned a random garbage value, right? Similar thing happens over here, and then and only then this 2000 is assigned to the year variable, which makes it inefficient because there are multiple assignments going on over there. On the other hand, this modern version, this C++17 version, C++17 version, what it does, it creates a data structure name with the data members initialized already, so there are no double initializations going on. Similarly, when you create an initializer list with dob 2011, it create these variables year, month, and day with the values 2001 and 1, so there is no garbage value assignment and then the year is assigned 2000 or something. There is no double assignment going on over here. And similarly over here, the status is created, it initialized with this value instead of first being initialized with the default value and then assigned this value. So this is much more efficient. Now we'll see different types of constructors. We'll overload this constructor just like we overload any other function. But before that, I would like to get into a single caveat about initialization list. Notice over here that the pattern in which the data is defined in the user class definition, it's name first, date of birth second, and status third, right? But my initialization list, if you notice, it starts with date of birth, status, and then it initializes the name. What does this mean? Does it create a difference? Is date of birth initialized before status, and is that initialized before name, or does that make any difference? It doesn't make any difference. The way you have defined your user class over here is the way these data members are initialized. So name would always be initialized before date of birth would always be initialized before status, no matter how you change them in the initialization list. Alright, now let's define a new constructor. So imagine, instead of just passing in no value when we are creating the user, what if we want to create a person, a user, with some default values of our own choosing? So let's do that. So we have a user, and this time let's start with a string, a const string that would be their first name, and another string that would be their last name, and then we will have an integer that would be their date of birth's year, another integer that would be the day, and another integer that would be the month, and then finally another string, constant string, that would be their status. So we can pass them all together as we are creating the object. For example, like this, let's create another object over here, user object b, and instead of ending it like this, what we can do is we can do this and pass the first name. Let's create Toqir, the second name Salim. It would give error for now, and let's pass the year 1998 for 5, for 5, and then the status, my status would be study C++, right? This would be my status. So I would like to create something like this, but if I run this, I don't have this defined right now. So let's define this. What's going to happen is we are going to take this definition so that we don't change anything. We're going to go over here and we are going to go like this, and we are going to use the initializer list again, but this time we are going to use them much more wisely and much more cleverly. So let's first give these data types a name. Let's start with fname, first name for shorten fname, last name is shortened as lname, this is year y, this is month m, this is day, and let's give this name status stat, right? And now I can create an initialization list just like I created one over here. I'll do one single column, and then I'll do name, I'll use curly brackets, and then I'll pass fname and last name into it, right? And then I'll pass the other one, that is date of birth, and I'll pass year, month, and day. And then finally, I'll pass in my initialization list, I'll pass the status, and there is status. And because status is not a structure that I created, it's a data type built into C++, I'll use round brackets, and I'll do over here stat. You see it's showing a lot of errors. Let's go one by one. Expected an identifier, and the problem is it doesn't even know what this user is. We have to tell it that this is a function within the class of user. See, so it should be user this, and all the errors will go away. Now it knows that, oh, this is a function within the class user, this is a constructor function, and it goes and compares what matches to it, and it finds this, and it's like, okay, fine, cool. And what's happening over here is that I'm passing in these arguments and using the initialization list to initialize using these arguments. And now when I do this, I actually have initialize cout. We have b dot get name, and we will get the last name this time. Last name. Oh, this is a function, so don't forget name function dot last name, and end up over here, end line. And we run this, and we should see Salim pop up over here, and that is actually the case. So this works. Before moving on to the other topics, let's talk about some coding conventions while defining a class. Over here, notice when we are defining the private and the public parts of our class, we are not indenting these things. I can easily indent them, and this would make our code much more readable. This would easily show what are the private parts, what are the public parts, right? And this is a coding practice usually used to make your code much more readable. It has nothing to do with code correctness, but remember, at the end of the day, you are not writing your code 99% of the times not for yourself, but actually for other people, and you have to make it easily readable for other people. The other coding practice is that instead of defining the private part first, you define the public part first. You do something like this, and then after this, you define the public part over here. Now, what's the wisdom behind doing this? And the idea is very simple. You are writing your code for other people to read, and they are most probably interested in using the class that you have defined, that you have come up with, as a black box. So they are not interested in the private data members, but they are interested in the public functions, so that they can use these functions to implement their own version of Instagram, maybe Facebook, and blah blah blah. So public should come before private because that's what people are interested in. Last time, a lot of students were confused about double pointers and why we were using double pointers in our implementation of person and network of friends in class. So let's begin. We will begin at the bottom of complexity ladder, and as we go up, the complexity will increase and things might get complicated. So we will go step by step, each step on a ladder. A lot of students would naively try to implement a user network by doing something like this. They would say, hey, other users are of the data type user, so why don't I do something like user follower? Well, there are two problems with this. The first problem is the red line, as you see. Let's see what it says. It says something like incomplete type user is not allowed. What it means is you are in an infinite regression of user. You are trying to define the class user by using the data type user. So there is an infinite regression, and C++ compiler is like, I don't know what a user is, it's incomplete, you can't do this. That's the first problem. And the second problem is this is a single follower. you need multiple followers, at least like 100 or thousands of followers, because that's what happens on Instagram. You keep following other people, you build a big network. So to fix the first problem, we will have to use a pointer to a user instead of actually using the user data type itself, and this would solve that first problem. Let's move one step up in the complexity ladder and implement it a bit more smartly. And this time around, a student might be like, okay, instead of using a single follower variable, I am going to create multiple follower variables like this. And you can have something like 2, 3, 4, and 5. Well, this will work, but only for 5 followers, right? And this is really ugly. So moving one step again up in the complexity ladders, a lot of students would basically reduce this down to something like this. They would say, instead of creating multiple variables, why don't we just create an array of pointers to user that is of size 5? But then students would realize, what if the network grows? What if a user has more than 5 followers? It would break down your network, it would break down your social media platform. So a lot of students, and actually a lot of companies, what they used to do was put a really big number over here and then assume that this is not going to be a problem in future. But guess what? Once you have people like Ronaldo, once you have people like who is famous on Instagram, I don't know other famous people on Instagram, Ronaldo or Messi, who have millions and millions of followers, your network breaks down. And this actually happened in case of Justin Bieber, where Instagram went down because of his number of likes on his post. So it was a similar case in their case. So how do we solve this? Well, to solve this, we have to understand, how are we going to change this dynamically. We know that we have to change this dynamically because otherwise there is no other way, because you don't know this size at compile time. The only way you can change the size of an array, or you can create a variable length array, is using dynamic memory allocation. So let's go back to dynamic memory allocation over here and remember how it used to work. So if I need to allocate an integer on the heap, this is how I do it. I do int pointer, pointer to integer, I call it x, and I do new int, right? So let's break this down. What this means is, this part means that I am going to allocate 4 bytes for an integer and return you a pointer, and that pointer we assign to x, which the data type is of integer pointer. Good enough. But let's move up one step again in complexity and try to understand, what if we need an array of pointers, right? In that case, we just used to do something like this, and we would take the input int n and cin n like this. Now let's move one step up in the complexity ladder and let's delete this, and let's say for some reason you don't want an array of integers, you actually want an array of pointers to integers, right? Remember, if I need like an array of doubles, so I would do double, right? If I want an array of strings, I would do strings. If I want an array of users, I would do users like this. But what if I want an array of pointers to a string, pointers to an integer? I would do int and I would give it a pointer sign, right? But immediately now you see a new error pop out. It says a value of type this cannot be initialized on an entity of type this. This, ladies and gentlemen, is a double pointer, and we have officially entered the triad zone. This is returning a pointer to a pointer, and we need to store that over here like this. Now, a lot of you might be confused. Whoa. Why did this return a pointer to a pointer, right? Remember, when I was doing this, or even this was returning a pointer to an integer, and that was being stored over here in a integer pointer, right? This was returning a pointer in the first place. So when I'm asking it to give me an array of pointers, or even forget about array, when I'm asking it to give me a pointer to an integer, so it would return a pointer to a pointer like this. So if you're asking for an array of pointers to an integers, you would need, first of all, the size, and you would need a double pointer to store that, because it's a pointer to a pointer. Now apply this concept to the followers concept. Remember, when we are going to dynamically increase the size of this array or this follower list, what's going to happen? It's something similar. Instead of integer, you would have something like over here user, and you would have over here user, because you would want an array of pointer of users, right? You want an array where each member of that array, each element of that array is pointing to another user, right? But remember what I said, this was already returning a pointer. So now when you are creating an array of pointers, it would return a double pointer, a pointer to a pointer. And this is one use case for double pointers. By the way, this is not always double pointers. Double pointers are much more versatile than this, but this is one use case of double pointers. Now that we understand why do we have a double pointer over here, let's create some functions such as adding a friend. That would be basically void add friend. Now when you're adding a friend, you need a pointer to that friend, pointer to a user. So it should be something like this. It should be, user, like this, right? And let's say I want to have a function where I can print out the names of all of my friends. So it would be something like void, let's say friend list or something like, let's do list. And do I need an argument over there? No, I would just use the user follower double pointer that I have inbuilt into my user class. And remember, this is a function defined within the user class, so it has access to the private data members, right? So now let's implement these two. Let's copy this and we'll go right over here and we'll have them defined over here. Remember, right now your compiler has no idea what these functions are and what these function and if these functions belong to the user class or not. To tell it that it belongs to the user class, you do something like this. I repeated this multiple times because students usually forget about these things. And you do something like this and something like this, and everything is fine and dandy now. So over here, let's give a name to this user. We can have something like friend. By the way, a lot of people would use this friend as a username. You cannot use friend as a name, as a variable name, because as you can see over here, it is a C++ keyword, and C++ keywords cannot be used as variable names. So let's call it f for now, and I guess that is good enough. And this is going to be something similar to what we have done in class. It's going to be basically, we are going to create a person double pointer, and let's call it new friends, and this is going to be a new list of friends, and we are going to do new person friend count. By the way, now we need another variable to keep track of how many friends do we have. So because we have lost that information by using double pointers instead of an array, so we will do something like int friend count, or follower count, actually follower count, right? We'll do something like this, and go over here and do follower count plus 1. Let me explain what's happening over here. I was wondering what this error was, and I remember we are defining it as a user, not a person. Now let me explain what's happening over here. We are creating a new array of pointers to users, and the size is the follower count plus 1. So that's because we are adding a new friend. This is going to be the current follower size plus 1. But notice, I've said this before, but I'll repeat myself again. This would return a pointer. But what would it return a pointer to? It would return a pointer to an array of pointers. So it should be a pointer to a pointer. So it should be a double pointer. So now we have this. Everything else is going to be the same thing. We are going to go in a loop of size I smaller than follower count, and we are going to copy the address of previous friends that we had in followers to the new friends. New friends I is going to be followers I. Basically, we are copying the addresses, the pointers of the previous friends we had from the old followers list to the new list or to the new array. I'm using list over here. Apologies for that. This is an array. I'm using Python terminology. And at the end of the array, at the last index, I am going to assign it, and the last index is going to be follower count, by the way, because we stopped just before follower count, and I'm going to assign it the new user, the new friend that we are adding. So now we have copied all of the old friends, and at the last index we have added the address or the pointer to the new friend. Now the new friend list is complete, right? So let's make sure that there are no memory leaks, and first we'll delete the old friend list, right? The old followers list. So follower, this is deleted, and then we will assign this follower list the new friends that we have made, the new list that we have made, right? And we will increase the follower count. Now let's work on the friend list function, right? This is going to be really simple. This is going to be a for loop where we traverse the entire friend list, and the size is going to be basically follower count, right? And we are going to increment it, and we are going to print the friend list. So we are going to go to the friend list. We are going to not friend list. We are going to go to the followers, and we are going to check them one by one. Now remember, over here, follower, an individual element of that is a pointer to a user, right? So if it's a pointer, I cannot use the dot operator to access it. It's already giving me an error. Then I have to use the arrow operator to access its member functions and member variables. And remember, this is a class. You cannot access the private data members anyways. So we will have to get the accessor functions that we created before. So accessor functions, we will use get name, right? This will return a data structure of a name, and it has two members in it, the first name and the last name. So I will do dot and first name. Over here I can use dot operator, and I don't need to use any accessor and getter functions because this is a structure and there is no privacy, there is no encapsulation of data. So I will do this, and then I will do a comma for the next name, and then I will stop over here, and at the end I will print out an end line. And with this we have our primitive Instagram completed, almost. So let's implement this. We have user A, and we have actually not defined them. So what we can do is, we have not defined their name. We can use a setter function, set name, and I can do something like over here, the first name is Kareem, the second name is Ahmed. This is one of my friends. And over here I can then do something like user C. This is going to be one of my friends, Farhan, and is going to be Ali, right? Something like this. So we don't have a special constructor function where we can ignore rest of these things, right? So we can actually create one right now. We can go up and see that we have a constructor function over here which initializes all of these values. But as I said, sometimes we don't want that. So what we'll do is we'll basically do this. We'll create one over here like this, and we will not pass the date of birth. We will just pass the first name, and we will just pass the status. So what will happen is we don't have this anymore, so we will keep this empty. We don't have y and any this, so we'll do something like a standard date of birth 2001, and this should fix the error. Oh yeah, yeah. But you see that there are red lines all over the place. Why are there red lines? Let's go and take a look at the error, and you see no instance of the overloaded function. We haven't overloaded this. The compiler knows this one, the compiler knows this one, but we haven't defined this within the user class definition over here. We have never defined it, or we have never declared it over here. So we have to declare it over here, and when declaring, we don't need the initializer list, we just need this. We also don't need the name, so we can just do this, right? And this is good enough. And now if we come down, we don't see the errors anymore because we have the declaration up there which matches the declaration definition over here. And now we have overloaded the function. Remember, we learned about function overloading. It's when you define a function with the same name, but it has either different number of arguments, either different data types in their arguments, or it has a different sequence of these data types of arguments. So compiler can differentiate between the same name based on the context. Over here the same thing is happening. Even though this is called a user, this is also called a user, and this is also called a user, all of them are constructors, but the compiler can differentiate between these constructors and can infer which constructor is called upon by looking at the context. So over here now I can have something like Farhan, and remember, this is going to be his status. He's from Gilgit, so I'm going to say Gilgiti, right? This is going to be the third user, and then I'm going to create for the user, let's call him Tanzil. He's going to be a Karachiite. He's also from Gilgit, but he has lived in Karachi for so long, so I call him a Karachiite. And let's call him D, and let's call him E, and this can be my other friend Taj Dar, and he is actually a really smart guy and a decent guy, so I'm calling Mr. Good Boy. Yeah, this will piss him off. Now let's make sure that Tokir user B is followed by all of them. He is the famous guy, so we will do b dot add friend, and this is going to be a pointer. Remember, it's already telling me it's going to be a pointer to a user, so I cannot do something like a over here. This will already create a problem. This is already giving me underline because this is an object, this is not a pointer, so I would have to give it the address over here, right? I would have to use ampersand to get the address of this user, and then I can do b dot add friend. I can do address of C. I can do b dot add friend. This is going to be CBCD. Excuse me for the question mark. And over here is going to be excuse me. I'm going to be over here like this, and this is going to be E. All of them are in my followers list. Awesome. Now let's test this if it actually works. Now what I'll do is I'll call the friend list function b dot friend list function, and this should in principle print all of their names with a comma. It should start with who was the first friend added, Kareem, then it should do Farhan, Tanzil, Tajdar, right? Let's run this and see if this works. This is running. Let's see the error, show errors, members, extra qualifications, user over here. Let's see. Oh, all right. So over here, this is a typical mistake that I usually make, and this has not gotten out of me. Notice that this is a good learning experience, by the way. Notice that this is a definition, right? And when we were defining the member functions outside of the definitions, we had to tell that this function belongs to the user. But I don't need to do this if I'm defining the function within the definition. And that's the mistake I'm making over here. I'm trying to tell it that this function belongs to the user class user, but since this is already within the definition, I don't need to do this. This is like an extra thing. It would actually say that this is extra qualification, right? This is you are being extra. That's what C++ is telling me. Now this should work. We should go back to the terminal and run this again. And this time it runs. So I have friends Kareem, Farhan, Tanzil, and Tajdar.